So hello students, a very good afternoon to all of you. So let's start the class. Okay. So yesterday I discussed little bit gamma function. Okay, let me start it again so you will have that proper idea. Yesterday we did some 2-3 questions. Okay. So basically what is gamma function? This gamma function, like generally in function is what? F of x equal to x square minus 3x plus 1. Here what is the independent variable? X is the independent variable. And fx is considered as the function. Right? But here, this is a function in which x is not the variable, and it is a function in which it is a function which is denoted by gamma function is a function denoted by gamma n. This symbol is read as, you will be reading as gamma n. The symbol is gamma only, okay? The name of the function is also gamma, and the symbol name is also gamma. And defined by integral. Defined by a definite integral as gamma n is equal to e to the power 0 to x 0 to infinity e to the power minus x to the power n minus 1 dx. So here this is a function of n. This gamma is a function of n. It is not a function of x. Here in place of x, p, r, t, whatever you put, the limiting variable is x, and it is going from 0 to infinity. That is okay, fine. So if you change the value of n, this value will be changed. Basically, any definite integral represents an area function. So it will represent some area, right? 4x, it is representing some area. So if you are changing the value of n, the graph of this complete function will be changed, and you will get different area. So it is a function of n, not x. I am saying again, it is a function of n. Gamma is a function of n here. X is fixed here from 0 to infinity. Whatever x in place of x, if you put p, r, m, whatever you put, it's okay. Are you getting my point? So here this n is coming here. This is a function of n. Already yesterday we did this part. So what is gamma of n? Gamma of n. Yesterday we did the value of gamma of n is what? Let me do it again, otherwise yesterday some students were absent. 0 to infinity. What were you doing? Can you tell me? So you were considering the function to be, which function I was considering to be? First function. So this function I was considering to be first function, this was I was considering to be second function. So okay, fine. X to the power n minus 1, e to the power minus x, integration 0 to infinity. Differentiation of this part is what? Is this the way? Again, do you remember the limits part? If you put infinity here, what is the differentiation? First, what is the integration? Now this part is what? N. Integration is what? So here I am writing n minus 1 x to the power n minus 2. It is nothing but e to the power minus x dx. Here I am writing this is nothing but 0. Do you remember how it is coming as 0? Because it is infinity to the power infinity form. Yes, limit x to the power n minus 1 e to the power x. X is tending to infinity. If you put 0, you will get 0 only. And if you are putting infinity, you are getting infinity by infinity form, but exponential is in the denominator. So if you differentiate, if you apply LH tool, here you will get n factorial, here you will get what? N minus 1 factorial, and here you will get e to the power x only. So n minus 1 factorial is a constant quantity, it's a finite value, and e to the power infinity is an infinite value, so you will get 0, if you remember. This is what, if you see, this is what, so it is nothing but e to the power minus x, n minus 1 minus 1 I can write. So here I am writing it is nothing but gamma of n minus 1. This is defined, whatever you put inside gamma, it must be positive. Whatever you are putting inside gamma, it must be positive. Try to understand, try to remember this part, what I am saying. So here it is, this is the function. So what property we have got? So therefore properties, yesterday also we have written some properties. Gamma of n plus 1 is equal to n into gamma of n, or I can write gamma of n plus 1 is equal to n factorial. We can write like this also. Similarly, here you have understood this gamma of n is n minus 1, n factorial, n minus 1 gamma. This is the basic property. I hope there is no doubt. Next, the important property is that gamma n can be written as z to the power n integration of 0 to infinity e to the power minus zx x to the power n minus 1 dx. Now you will say, sir, what is z? So I am saying here z can be any real number, positive real number. Whatever you are putting inside gamma, that must be positive, and here z must be positive. This is the property number 2. Okay, let's prove it out. Let's prove this property. It is important. Whenever required, we'll be using it. We will be using it whenever it required. So just to prove this one, I am just using x equal to z of t. That's all. So by using this, how the limits are changed? Whenever my t was, see here. So d of x is equal to z of t, and limits when x was 0, z is 0. Sorry, t is 0, z is a constant quantity. T is no new variable is 0. When x is infinity, t is infinity. Correct or not a doubt? Okay, fine. So how the things are changed? See, 0 to infinity, e to the power minus. In what I am changing? This is my function. Let's start it from here. Gamma n, we know. I'm changing here only. Don't get confused. What I'm changing, I'm making some change here in this part. Therefore, e to the power infinity gamma n, e to the power minus z of t now, x is what zt n minus 1, dx is z t. Okay, fine. So here we are getting like this. So it is what z of n. So z is a constant for this integral, so it can come outside obviously. E to the power minus zt, and this is what t to the power n minus 1 dt. So j, t, m, p, r, a, the name of the variable by using property number 1 of simple definite integration. We are writing e to the power minus z of x, x to the power n minus 1 d of t. Have you understood this part or not? Gamma of n, where z can be anything you can introduce according to our need. According to our need, we can introduce anything which is required. Understood this property? Understood or not, beta? This is the property. Number 3, let me write number 3. Number 3 property, see. Yesterday we did one question, now I am giving it as a property. Because with some good question, you should remember this is a property. Log of 1 by y. Gamma n can also be written. One of the form of writing gamma n as well is what? Log of 1 by y to the power n minus 1 dy. Or you can write dx also, doesn't matter. Y is the integrating variable, or you can write it in terms of x also. It's your choice. It's completely your choice. Proof. We have by definition of gamma functions, what is we are having? Gamma n is equal to 0 to infinity e to the power minus x, x to the power n minus 1 dx. This we are having from definition. Now see, we have to convert into this part. So log of 1 by y. Log of 1 by y, it is there. How can you do? Yesterday we did this question, if you remember. Yesterday we did this question. That is the property. The proof, you can write the proof from yesterday's class. Or how to do the proof. Can you tell me once? Sir, x to the power, so this is to the power n minus 1. Something in gamma to the power n minus 1 is x. No, so we should consider this as x. So what we should substitute here? X is log of 1 by y. Okay, fine. So 1 by y is e to the power x. Y is changed by e to the power minus x. Okay, done. Now, dy is equal to e to the power minus x dx. Give the change. How the limits will be changed? If x is my 0, then y will be what? If x is 0, then what? Y will be e to the power minus 0. That is 1. So y will be 1. Not an issue. Understood? If x is infinity, then y will be what? E to the power infinity, y will be tending to 0. Yeah, these are the changes we have observed. Therefore, from here, gamma n is equal to what limits we have to put? 1 to 0. Okay. This is what e to the power minus x will be changed to what? Y. X to the power n minus 1 will be changed to log 1 by y to the power n minus 1. Correct only? Yes. Am I right? This will what? Dy will be changed what again? Dx will be changed to what? Dy only. Or here I should write, no need to write this part. Because minus of dx dy is what? Minus dy. So minus of dy. This minus I am writing in the front. Log of 1 by y to the power n minus 1 dy. So again, this due to property number 2, the limits will be interchanged to consume this minus sign. So 0 to 1, log of 1 by y or 1 by x, whatever variable you want to use, you can use dy gamma n. This can also be termed as one form of definition of gamma function, where the limits are from 0 to 1. In all of the definitions, limits are from 0 to infinity, but in this definition, the limits are from 0 to 1. And you can get this as a question, or you can remember this as a property also. It's your choice. It's your choice completely. Number 3 you're done. Number 3 or 4 it is. Yeah, 3 only. Number 4, let's see. Number 4, gamma of n plus 1, you should write 0 to infinity e to the power minus y raised to the power 1 by n. E to the power minus y raised to the power minus 1, raised to the power 1 by n dy. Here you understand, sir, variable naam mein kya rakha hai? You can write y as x, p, m, r, whatever. So this is also one of the definition of gamma function. How to prove this definition? See. So how to prove this definition? Again, I am starting with my definition by gamma function. Gamma function. Today's class is important. Just go through the class. See, for JEE, they don't ask much questions from JEE mains. In JEE mains, they won't ask much question. But okay, you should know the theory part. You should know everything. You should be comfortable with this. Okay. So just focus on the class. Each and every property you should remember. You should know how to do the substitution. And each and every property is basically can be proved by a simple substitution only. You should be very careful in those substitution. So here we have to prove this one. So gamma n is what? Already we know. So e to the power minus x, x to the power n minus 1, dx 0 to infinity. This by heart we have remember. Now this part is required. So e to the power minus x is there. So e to the power minus is something is there. So that let's write that substitution. You should get the idea of how to substitute. X is what? Y to the power 1 by n. I should substitute like this. Okay, so that means what? X to the power n is y. Differentiating x to the power n minus 1 dx is equal to dy. This is the way of limits. How limits will be changed? When x is 0, y will also be 0. When x is infinity, y will also be infinity. Simply. It's very obvious. Now, let's put it down here. 0 to infinity, e to the power minus x. So, e to the power minus y by 1 by n. x to the power n minus 1 dx. X to the power n minus 1 dx is what? Dy by n. Correct? Now what about this n? So this n is what? So let's see. So we are getting here lambda gamma n is equal to this. N into this n is a constant for this integration. This n can come outside. So n into gamma n is what? This one. Now I hope you have understood from the property number 1 of gamma function. It is nothing but gamma of n plus 1. Gamma of n plus 1 is 0 to infinity e to the power minus y raised to the power 1 by n t1. So you can remember this property. Understood or not? Yeah, please tell me. Any doubt? Please tell me. You can ask for any doubt till now what we have studied. Written? Yeah, next. No one is raising hand. No doubt, very good. Next, yesterday also we did some properties, if you remember. Yesterday also we did some properties, if you remember. What are those properties if I write? Number 4 is done. Number 4 is done. Here I am writing again. Some properties I will be proving after beta function. Some properties we will be putting after beta function. That is 0 to pi by 2 sine to the power mx cos to the power nx. It is yesterday we also see we can relate this function with the Wallis theorem also. Gamma of n plus 1 by 2, gamma of n plus 1 by 2, gamma of twice of gamma of m plus n plus 2 by 2. This is one property we can relate. And gamma of half is root pi. This we will be proving later on today in the today's class itself. Gamma of n, gamma of 1 minus n is equal to pi by sine of n pi, where n should be lying from 0 to 1. Okay, these are the properties. Here this is important one. Here this is important one. We'll be proving it. Okay, this is also important one. We'll be proving all the relations. So you should remember these properties first of all. Is it clear to you? I guess. Okay, so we already did some question on gamma function that we'll be relating again whenever required. Now let's put the heading. This is our gamma function. Is it clear? Now let's see. Beta function. Beta function. Write down the definition of this function. This is very much similar. The definition is similar only. The beta function. It is like we made this function because after making this function, it can be seen that this can be used many times in very different type of question. These functions can be used in your engineering mathematics. When you move to your engineering colleges, you can see that in your first second year, you will be learning this gamma function, beta function in a very vast way. Very useful for engineer student. Very much useful for every engineer student. Every engineering student. Okay. The beta function is denoted by beta of Mn. What is the difference, sir? Here there are two variables of the beta function which are n comma n. both where m comma n both should be positive, where m comma n both should be positive, okay, and defined by a definite integral as beta of m comma n is equal to, it is also a definite integral which is defined like this: x to the power m minus 1 1 minus x to the power n minus 1 dx. This is the definition of this beta function. You should remember it is also representing an area function, because every definite integral represents some area function. If you change m comma n, the value will be changed, because okay, so what is the variable of this beta function, if anyone asks? So there are two variables. It is a two variable function m comma n. It is a two variable function m comma n. I hope it is clear to you. Let's write down the properties. First property, beta m comma n is equal to beta n comma n. Yeah, please tell me. Please, Riya.
So x is not a variable in this case.
No, x is not a variable. For this beta function, m comma n are the variables.
Then what is x?
X is the integrating variable. It is a function.
Okay,
Of,
okay.
It is a function in which integral is used. Are you getting my point? If you change m comma n, the value will be changed. But if you just write down the name as x, if you replace x by p, you are writing, because it is the integrating limiting values are fixed 0 to 1. So if you write x as p also, then you will get the same thing. If you write x as m, x as r also, then the integrating limits 0 to 1 are fixed only.
So that's the integrating variable. For the function, the variables will be m and n.
Yeah, exactly.
Okay.
It is a function in which integration is used. It is the integrand is used. Are you getting my point?
Sir. Yes, sir.
Yeah. First property, m comma n can be written as n comma n. It's very simple. Simply can be proved by our basic fundamental properties of definite integration. Beta m comma n is what? 0 to 1 x m minus 1 1 minus x n minus 1 dx. So you can simply by property 5, if you remember, x can be replaced by 0 plus 1 minus x. So 1 minus x m minus 1, it is what? 1 minus x is replaced. Simply I am getting like this, what? 0 to 1, 1 minus x to the power m minus 1, and it is x to the power n minus 1. And now you can say, sir, it is nothing but beta n comma n. Hence property number is proved. Property 1 is proved only. It's very simple property, right? Number 2, see beta. Number 2 property is very important. The different form of definition of beta function. Beta m comma n can also be written as 0 to infinity. Here what are the limits? Limits are changed. So here the limits are 0 to 1. Try to understand. In the original definition of beta function, limits are 0 to 1. In the property made definition, the limits we are writing is 0 to infinity. And we will be proving it. X to the power n minus 1 by 1 plus x to the power m plus n dx. It can also be written as 0 to infinity x to the power m minus 1 by 1 plus x to the power m plus 1 dx. That's very obvious. Let's see the proof. The proof I am giving. See, something should be in our denominator. Try to understand. X to the power n minus 1 is there. Okay, fine. X to the power n minus 1 is there. Originally we have. Let's write like we have. Beta m comma n is we are having 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1. Now you should get this one. So limit should be changed from 0 to infinity. That means what? X should be replaced as 1 by t or something like that. Because if you put 0, you will get infinity. 1 by t you will be putting. And here it is n minus 1, it is there. But in denominator it is a 1 plus x is there. So according to what we have to prove, we are doing some substitution, and just see what substitution we are putting here to prove it. In numerator 1 plus x is there. In both the case 1 plus x would be there. So see the substitution, you will get the idea. 1 by 1 plus t and write. Substitute. Put, or let me write here. Okay. Put x equal to 1 by 1 plus t. Okay, fine. So if I differentiate, what will I get? See, first differentiation. Minus 1 by 1 plus t whole square dt. Limits, how will be changed? If x is 0, if x is 0, then if x is 0, then simply I can write 1 plus t is equal to 1 by x. T is equal to 1 by x minus 1. So if x is 0, t is infinity. If x is 1, t is 0. These are the things we have got. Now therefore I am writing here, it is what? Infinity to 0 I am writing. Try to understand. X to the power m minus 1. X is what? 1 by 1 plus t to the power m minus 1. Any point, anyway you are doubt, any step you are having doubt, please raise your hand. 1 by 1 plus t m minus 1. Dx is what? Minus 1 by 1 plus t dt. Okay, fine. We are getting these things. Now what? See, this minus sign, let's make it, put it forward in the front. And you have already observed this minus will be used to interchange the limits. Now here, 1 by 1 plus t to the power m minus 1 is there. After simplifying and taking LCM, you are getting 1 plus t minus 1 is what? T only. T to the power n minus 1 by 1 plus t n minus 1. This minus I have already utilized. 1 plus t whole square dt. Okay, fine. So this is t to the power n minus 1 by 1 plus t to the power. This minus I am utilizing to interchange the limits, so it will be 0 to infinity. And this is what? M minus 1, n minus 1, 2. So you have understood, so it is like this only. And anyway, you can change the name of the variable whenever required. So it is what? T to the power, t I am writing again as x. 1 plus x to the power m plus n dx. Now, what is what they are asking to prove? This is equivalent to this, this is equivalent to this. We already know from property number 1, beta mn comma beta nm. This, if I replace n by m and m by n, you will get same thing. So this is equivalent to this because here n and m are replacing. So I can write this is what? This is equivalent to as x m minus 1, 1 plus x to the power m plus 1 dx. As beta m comma n is already we know beta n comma n. So this is what? Beta n comma n. So beta n comma m is what? N and m will be replaced. So this will be equal to this. So hence both are equal. Have you understood? Have you understood or not? Please tell me. If not, please tell me. Raise your hand. Write it down. I think everything is clear to you. Fine, write it down. Okay, fine. So here we have gone through second property. Let's write down the third property also. Let's write down third property in the new page. Or you can write it out here also. Third property I am writing here, gamma function third property, sorry, beta function third property is what? Beta see, beta of m comma n is equal to twice 0 to pi by 2. Like see, earlier the limit was 0 to 1. Now this is the property in which a function, algebraic function, can be transferred into a trigonometric function. Try to understand. And the limits will be changed from 0 to pi by 2. Yesterday in one girl asked me, sir, how the limits were changing into pi. So this is the form by which you are using substitution into trigonometric function. Trigonometric function substitution we are using here. Proof. What we have, we always start with our definition. Beta of m comma n we are having 0 to 1, x to the power m minus 1, 1 minus x to the power n minus 1 dx. Now you have to convert into in terms of twice n. Right? So what I am doing here, x I am considering as sine square theta. Just substitute, just assume x is sine square theta. That's all. That is the manipulation or important point of getting the result. 2 sine theta cos theta d theta. If you do this substitution, how the limits will be changed? Can you tell me? How the limits are changing? So whenever x is 0, theta will be 0. Whenever x is 1, theta is pi by 2. I hope you have understood this part. Therefore, beta of m comma n I can write as 0 to pi by 2. And x is what we have substituted. Sine square theta m minus 1. 1 minus x, 1 minus sine square theta, that is cos square theta obviously, n minus 1, into twice sine theta, cos theta, d theta. I think you have got the result. It is 2, it's coming outside, 0 to pi by 2. Sine square theta. Sine square twice n minus 2 plus 1. So sine theta twice n minus 2 plus 1. So twice n minus 1. 1 minus cos square theta, 1 minus sine square theta is cos square theta, cos theta 2 to the power n, twice n minus 1. This is the proof of the property number 3. This is an important proof. From this proof, actually, property number 5 of gamma function will also be proved. Understood? Is it clear to you better? Very good. Write it down. Just write it down. Property number 3. Property number 3, write it down for beta function. Yeah, having doubt, please raise your hand. Mr. Kirti Sharma, Vagdevi.
Sir,
Tell me.
even though we take x is equal to cos square theta, we'll get the same thing, right?
If you are getting here, same. No. Cos square theta limits will not, you will get, sir. Cos square theta don't consider. So, one thing you know what? Always try to convert in terms of sin square theta. Why? Because if you are considering cos square theta, 0 to 0 limit you will get in. 0 to 0. Are you getting my point? Because it was originally 0 to 1. So, limits will be what? Pi by 2 to 0 you will get, I guess. Right? So, again you have to take, you will get, but again you have to take minus common, aega, to aa jayega, you will get only. But more chances are there that always try to convert in terms of sin theta.
Okay, sir.
But the more suitable substitution is this one. But obviously you can convert in terms of cos square theta also. That is also obvious. You can do.
Okay, sir. Thank you, sir.
तो ठीक है फिर आगे बढ़ते हैं. So these are the properties of beta function. I am moving to the next page. Very, very important. Relation between gamma and beta function. Relation between gamma and beta function. See. So what is the relation? First you should remember beta of m comma n is equal to gamma of n, gamma of n, gamma of n plus n. See, gamma of n, we can find a numerical value, factorial and all the formulas we are having. And beta of m comma n can be replaced in terms, can be written in terms of gamma. So this is the relation between gamma and beta function. Very, very important relation. Let's try to prove this definition. Let's see how to prove. But obviously very much important relation it is. Okay. Sincerely try to observe it. By definition, let's move with definition only. By definition of the gamma function I am writing here, gamma of n is what? So 0 to infinity e to the power minus x, x to the power n minus 1 dx. Okay, fine. Again, we are having one more definition. If you remember, there is one more definition. If you remember, do you remember? So no, 0 to the power infinity. Let me write it down. Very, very important part I am writing here. Z is what? Any random value you can put. Just positive it should be. E to the power minus zx I am writing. Try to understand. X to the power n minus 1 dx. So from where it is coming? So from where it is coming, if you forgot, let me explain. It is coming from the property number. It is coming from this property. See, property number 2. I am using this property. Those who have not understood, please observe here. Look at here. I am using this property. Gamma of n is z to the power n. Z can be anything positive. Z can be anything positive. So I hope you have understood this part. Okay, very good. Now I am writing this gamma of n is what? Upon z to the power n, 0 to the infinity e to the power minus zx, x to the power n minus 1 dx. Just observe this one. How we are writing? ये कैसे लिखा जा रहा है? See, it's gamma n is there. So this n is here, similar to this. Since n is this one n is similarly. Since n is there, here also we are writing n. That's all. Whatever with the gamma function of it is a gamma of n. That's why you are putting power n here. What is z? The simple any arbitrary constant we are putting here. That same thing we are putting here. यहाँ z है, यहाँ z है. See how to relate, how to remember things. Similar things. Z यहाँ रखा, यहाँ z रखा. The gamma of function n is there, so we are putting the power n is there. Gamma n. These three things should be same. N. This z and this z should be same. Okay. You should remember why I am saying, because I will be directly using this function. I will be directly using this function in the later part, so that you can understand. Okay. Very good. So multiplying. If you don't understand proof, then also it's okay, but try to understand, obviously. Multiplying 1 by z to the power m minus 1 into e to the power minus z. Okay? I am multiplying this part. This is what? Z to the power m minus 1. For this, in 1 I am multiplying. So in the left hand side, gamma of n into z to the power m minus 1 into e to the power minus z. Okay, I'm multiplying here. We can do this one. Yes, correct, sir. E to the power, here also I'm multiplying the same thing. E to the power z of m minus 1 e to the power minus z. Earlier, originally it was present e to the power minus x into x to the power n minus 1 dx. Is it correct to you? Correct only, sir. What is the problem? No problem. Any problem? Please tell me. Better, we just wait. Multiply. I am writing 2 here. Multiplying 2 here, okay? These 2, by multiplying with this part. So it will be z to the power n will come here also. Multiplying with this part. Okay, till now, no problem. What is the integrating variable here? Dx. X is the integrating variable. So everything which is free from x is constant for this integration. No issue. Okay. Now integrating. Now I'm integrating with respect to z and putting limits z equal to 0 to z equal to infinity. Okay, that means we have to put integration symbol here on both sides. Z to the power m minus 1. This from our side we are doing dz 0 to infinity. Here also we have to do this one. Z to the power m minus 1 e to the power minus z to the power n, double integration it is, e to the power minus x to the power n minus 1 dx dz 0 to infinity. Any problem? No, sir, no problem. Very good, very good, very good. So here, this n, gamma of n is a constant for this. Gamma of n is a constant for this integration because for the variable of this gamma n is what? Z only. So you can consider, you can take common Z, n common you can take gamma of n. All right. What can you write here? Sir, for this integration, everything which is consist of Z is constant only. So you can take out and you can again put this inside of integration also. This is a constant quantity. Like twice of dx you can write, then you can write twice of dx. From here to here you can go. From here to here also you can go. You can put the constant outside whenever required. You can put the constant inside whenever required. Is it clear to you? So here I am putting the constant inside when it is required now. So what I am doing here, 0. And just this is the constant quantity for this integration I am writing inside. It is got z to the power m minus 1, e to the power minus z, z to the power n into e to the power minus x, x to the power n minus 1, dx, dx, dz. Now both the integration, both the definition are having same limits. Both the integration and definition, both the integral are having same limits. You can, so in this type of question, so this is very upward engineering level mathematics, but in this type of question you can integrate whatever variable with whatever variable you require first, because both the variables, both the integrating variables are limits are same only. So okay, so what I am doing here now, if you just observe this part, so it is nothing but whatever like z, m, p, r, kuch bhi ho, it is a constant, it is a gamma m function or not. Just observe and say, check it out. Am I doing anything wrong? So it is gamma of n function only, nothing else. Like earlier it was x, here it is z, here it is p, m, p, whatever, it doesn't matter. It is a gamma of m function only. Okay, nice. Am I right? Very good. 0 to infinity, 0 to infinity. Now let's write it clearly. E to the power minus z. Minus z is there, and this is what? X is there. Okay, fine. Is there anything zx is there? Zx? Is there any zx is available to us? Sorry. I have multiplied by 2 only, na? This should be zx. Okay, this should be zx, obviously. Multiplying by 2 only. This is z of x. Is zx. Okay. So what is e to the power z minus z I am taking common, so it is 1 plus x, you can write. This is utilized. This and this is utilized. These two part I am utilizing here. What about z to the power common? M plus n minus 1. What is this x? X to the power n minus 1 d z into dx I am writing here. We can write like this, not an issue. 0 to infinity, 0 to infinity. Changing the, so here let me write one thing. First d x was there, dz was there. So just write one statement, changing the order of integration. First we are integrating with respect to x, now we will be integrating with respect to z, and we can do this if the integrals are having same limits. Changing the order of integrals. Integration, okay? Okay, fine. So earlier we were integrating with respect to x first, now we will be integrating with respect to z first. E to the power minus z, 1 plus x is there, into z to the power m plus n minus 1 is there, writing dz. And what is constant? What is constant for this integration? X to the power n minus 1. Because x to the power n minus 1 is constant for this integration, because this integration is having variable z only. And this integration is having this integration is having variable x only. So we are writing like this. Okay. Now I am writing gamma of n is equal to this. So gamma of n is equal to this. So let me write like this, but x to the power n minus 1. What about this part? Can you see anything? So we are not able to write this part. What is it? See, observe this nicely. e to the power minus j. What is the limiting variable here? What is the integrating variable as z here? Z is the integrating variable. Okay, fine, leave it. If I see what is the power, just observe like this. Okay, very very important. Where it is, where I have written. Not here. Okay, fine. Here only it is. Observe here. See. Observe here. What is gamma n? What is the variable? Integrating variable x only. Okay, fine. Z is a constant quantity here. E to the power minus zx, x to the power n minus 1. I am writing like this. E to the power minus zx. Constant integrating variable is x. Okay. X. Here integrating variable is z. What is the constant quantity? Like what we have used here as z. Here we are using it as 1 plus x. What we have used as z, here we are using as 1 plus x. Try to understand this part. Very, very important. I am writing this what? 1 plus x I am putting in the denominator. As z was in the denominator, z was there, z is here, z I am putting in the denominator. What is the x to the power n minus 1? What is this used here? N is used here. Here what is used here? M plus n is used here. So here it is function of gamma n plus n. 1 by x raised to the power 1 plus x z raised to the power n. This is n, this is also n. This will also be same. यहाँ n है तो यहाँ पे भी n होगा. Here 1 plus x to the power n plus n. Have you got it? This I am using here. Try to understand. So gamma n integration of e to the power x to the power n minus 1 I am writing. See here. Try to observe. Don't get x to the power n minus 1 by 1 plus x to the power m plus n. Okay. Integration is dx. For this integration, anything which is other than x is a constant. So gamma of m plus n is constant only. Gamma of m plus n is a constant only. Gamma n from property number, it is nothing but beta of m comma n. From property of beta function x to the power n minus 1, if you remember, see, x to the power n minus 1, if you remember the property here, I have written, see this one. Beta mm is what? 0 to infinity x to the power n minus 1, 1 plus x to the power n minus 1, 1 plus x to the power n plus 1. Remember, this property I am using, this is nothing but beta n comma n. See here. This is nothing but beta n comma n. So hence we have found a relation between beta and gamma function. And this is the relation we have written here. Beta n comma n is nothing but gamma n upon gamma n plus n. I hope you have understood this part. If not, please ask. Yeah, just write down once. I am giving you time. Everyone please write down once and see at what point you are getting confused. And everyone please write down with peaceful mind and write down. After writing down, you will get to know that, sir, that this step is not clear. Then ask the doubt and ask me the doubt according to your actual confusion. Otherwise, no use of asking doubt.
So over there, when you took Z, right, you said that was any positive number. And then after that, you're treating it as an integrating variable. How can you do that? I mean, isn't it supposed to be some?
Yeah, it is possible only. Z is just a variable. Now it's like we are putting something Z. Now Z is not fixed. Now it can be anything, but it is an arbitrary constant. It can be anything. Now we are integrating with respect to Z only. It is our assumption. Don't get confused. We can integrate. We are multiplying, but we are manipulating the things.
Is it? No, I thought like.
Yeah, is it correct? Is a correct statement. We can do this. We can do this. Not an issue. We can do this. It is not that constant. Exactly what you are saying. It is not that constant. Hana. It is not like 2 and 3 or 5. It is not like that. It is not 2, 3, 5. It is an arbitrary constraint. It can have any value. That is what I am saying. It can have any value.
So it's still an integrating variable.
Yeah, we can
It's
treat.
just,
Yeah,
it's
we
just
can
not
treat.
a part.
No, we can treat. We can treat we can treat it as an integrating variable whenever required. Here we are multiplying and we are treating, because first we are multiplying with this part and we are treating with, when we are treating like it is an integrating variable. So yes, we can do this question. We can do this part.
Okay.
Not an issue.
Yes, sir.
It is higher mathematics, higher engineering mathematics, so you might be confused. Double integration and everything is there. So if not understood, then also it's okay. Ultimately, what is required to us? This part is required to us.
Double integration is a bit confusing to me.
Yeah, that's what I am saying. If it is not understood, then also it's okay. Which part you have not understood? Just tell me.
So the double integration is.
Yeah, changing the order of integration. Earlier dx was there. Here I am writing dx dz. पहले हम dz को कर रहे हैं, फिर dx को कर रहे हैं.
Yes, sir.
At what point you are confused now? You may be confused with this. This how you have written this is equal to this. This I am using this part. I'm just using this box, whatever written in the box. I'm just similarly whatever written in the box. I'm using this formula. I'm treating this and I'm writing. This part is similar to that one. You do one thing. Just write down this one complete proof and see what steps you are getting confused.
Yes.
And then ask me again.
Yes, sir. Sir, can I say that gamma m multiplied by gamma n is the same as gamma of the product of m and n? Is that true?
Sorry? Is it you are saying that gamma mn is equal to gamma m into gamma n?
Yes, is that true?
No, it is not true.
The same. Okay, it will not
No, it is obviously not.
What about factorial? Even then, I don't think it will be the same.
So obviously factorial is also not true. 2 into 5, 10 factorial. So is 10 factorial is equal to 2 into 5? Is it true?
Okay.
Obviously no.
Okay. Thank you.
But it is not exactly like factorial. There are many conditions actually.
Yes.
There are many conditions. Just write it down first.
Thank you.
So this thing is clear. Property that means proved that gamma of half is equal to pi root pi, and gamma of this property also we have proved this one. I hope it is clear to you. Should we move forward? These are the properties we have proved by using beta and gamma function both. Beta and gamma function both. Understood? Some properties are also there actually, relation you should know. Let's write it down. Application part. First thing I am writing here. This also sometimes as a property can be used, so you should know. X to the power c, c to the power x. Improper integrals. These are all if the infinity is the power, limit is infinity, this is known as integral, improper integral. And you know what? Yeah, last week I think they have not asked the question on limit of sum. Integral is a limit of sum. They didn't ask any question. This week they definitely will be asking on the question of limit of sum as an integral. So just today practice those questions also. You have the exercise. I have already sent you the assignment, and you have already completed. Very easy questions are there. But today again you have to revise those questions. Definitely, I am sure that they will be asking questions from limit of integral as a sum. You getting my point? Limit of sum as an integral, they will be asking question tomorrow, day after tomorrow. That means mains exam, they will definitely be asking questions. So please go through it once. This is also one of the application which it can be given as a question. So let's try, and if possible, try to remember. If possible, and if not possible, leave it. Not possible, just leave it and see the process how to prove. That's all. So gamma n is what? 0 to infinity e to the power minus x to the power n minus 1. We are starting with the definition. Always in the functions or in the questions of gamma and beta, always start with the definitions only. Obviously n is positive here. Now what we have to prove? We have to prove this one. Okay. Let I equal to 0 to infinity x to the power c, c to the power x dx. X to the power c is there, here x to the power n minus 1 is there. So basically, first of all, and here it is c to the power x is there, but here in the question of gamma, it is what we have. We know, this we know, and we want to convert in terms of gamma only, because see, it is not pi, it is not root, huh? It is not root, it is gamma. It is gamma only, beta. Gamma of c. So definitely we have to convert in terms of gamma. Now I am observing here, it is e to the power minus x, it is c to the power x. Put, substitute here, c to the power x is e to the power x. What we are doing, try to understand please. C to the power x is e to the power x. Because c to the power x is e to the power x, so here it will be e to the power x and here it will become e to the power minus x. So I am trying to convert it into the form of gamma function. And what we are doing for this transformation, what we have to do? Put log on both sides or put ln on both sides. Putting ln or log on both sides, whatever you want to put log c x log of e to the power x. So it is x log of c, it is x only, because log is 1. Ln and log is 1 basically. Okay, so x is what? Here what I'm, sorry, I have to change the variable only, na? I have to change the variable, obviously. Obviously, I'm substituting, so I have to change the variable. So c to the power x I am putting as e to the power t. So it is t only. So x is nothing but t to the t upon log of c. Can't be differentiated. dt by log of c. सही है भाई, बिल्कुल सही. How the limit has changed? Is limits changing or not changing? Let's see. So if x is 0, see here. If x is 0, so at that time t will also be 0. If x is infinity, so t will also be infinity. No limits. From here you can see. You can see the limits part from here. Okay. So these limits are not being changed. What is changed actually? X to the power c. X is what now? T upon log c. Okay. T upon log c to the power c I am writing. C to the power x is what? E to the power minus t. Okay. Dx is what? T upon log c. So here I am getting I as log c is a constant quantity. If you see, observe it nicely. E to the power minus t, t upon c, t upon c, t to the power c, log t, log of c, c plus 1. Log c and everything including c is a constant for this integration. You can take it common. And this is what? 0 to infinity, e to the power minus t, t to the power c plus 1 minus 1 I can write. So this I is nothing but you can write as what? This, if you observe, it is nothing but gamma of c plus 1. See the definition? Log of c to the power c plus 1. Hence proved. Hence proved. Any doubt? Please ask me the doubt. Any doubt if you are having? Or I think we should move forward. Let's go fast. We should move forward, I guess. I think you are not having any doubt for this question. It's almost clear. Next, moving on. Application number 1, application number 2 I am writing here. I will be sending you the PDF so that you can write it later on. Number 2 application is what? See, beta m plus 1 comma n pi m is equal to beta. Sometimes if any such question comes, you should remember. This is the fun property about beta function. You can change the beta like this. Now you can change if required. How it's very easy to prove. You can prove it simply. You can start with beta, suppose n plus 1 by n. So it is what? By using the relation of gamma function and beta function. It is again not root. It is just gamma function by m plus n plus 1. So what do you know? Gamma of m plus 1 is what? M into a gamma of m. Property of gamma of m plus 1 is what? N into m plus 1. If you remember the property, do you remember this or not? This is a property of gamma function only. You should remember. How can you forget? It is writing m of gamma of m. It is n only. This is what? Gamma of m plus 1. So gamma of m plus 1 I am writing. M and cancelled. And this is what? Gamma of m, gamma of n, gamma of m plus n. So is it not beta m comma n by m plus n? Similarly, you can prove this one also. Similarly, you can prove this one also. How? Just write n plus 1. Same thing. In the numerator, you will get what? N plus 1, n into n, n into gamma n. N will be cancelled, you will get this one also. It's very simple, I think. Is it clear to you? I hope it is simple only. Yeah, tell me. Anyone raising hand, please tell me.
So the second part, so can you once repeat how to prove the one in between?
This one.
Huh.
Okay, let me prove that. So here it is what? Beta m n plus 1 by n. What can I write? So it is nothing but gamma of n plus 1 using the relation gamma of this plus this and divided by n is already there. Now we are having the property of gamma function, gamma of n. This n plus 1 is n into gamma of n, you can write. And this again m plus n, gamma of m plus n, you can write this. N is getting cancelled. Now what I am taking common? M plus 1 I am taking common. What is left? Gamma of n by gamma of m plus n. This is nothing but beta of m comma n or n comma m, whatever it is. This is not the correct. Same thing only. Understood? Let me write property number 3 also. Application number 3. Application number 3. Beta of m comma n can be written as beta m comma n plus 1 plus beta of n plus 1 comma n. See, simple property, important but simple and important. Proving it's very simple. Let's prove it out. Write down first RHS, because from proving from RHS it will be simpler. Proving from RHS it will be simpler. So see whatever it is, beta of m comma n plus 1 plus beta of m plus n comma n. What is it beta? Gamma of n, sorry, it's gamma. Gamma of n plus 1 by gamma of m plus n plus 1. Gamma of m plus 1, gamma of n. You can take LCM very simply. You can take LCM or not? Yes, sir. So I'm taking LCM. Here I am writing first gamma of n into gamma of n. Taking LCM first. What can I write here? N plus n is what? N into gamma of n into n. Here n plus 1 is what? M into gamma of n into n. Product only. What can I take common, sir? What can I take common? If you can see m n, you can take common. This you can write in the denominator is m plus n, gamma of m plus n. What is left in the numerator? M plus n. You can see these are getting cancelled. So gamma of n by gamma of m plus n is nothing but beta of m comma n or n comma n. That is what we needed to prove. Write it down. From with whatever is required, write it down. Just write it down. Yeah. So I hope it is written. Let's move to the some application part, questions part. Write down some question. Evaluate 0 to infinity e to the power minus x square dx. Question number 1. These are all the question of gamma and beta functions. Question 0 to the infinity e to the power minus 4x x to the power 5 by 2 dx. Okay, beta. Number 3, e to the power 0 to 1 x to the power 5 1 minus x cube to the power 10 dx. Number 4 is what? 0 to infinity e to the power root x e to the power minus 3 root x dx. Should I give you the hint? But you have to do all these questions by yourself. Okay, I am giving hint in each question. Here, minus x square. These are homework. These questions are homework only. So I am giving you hint. What can you do? X square is t. Put x square is t and see whatever you are getting. Right? So e to the minus x you should get. Okay. Number 2 hint here. What is the hint? Minus 4x is. Can you tell me the hint here? Here the hint is 4x is t. You will get the answer. Change the limits accordingly. Can you tell me the hint here? What is the hint here, beta? Here how you have to substitute? X cube is there first of all. X cube is there and it is a beta function. So beta function क्या होता है? Y to the power something 1 minus y. So x cube I am considering as t. X cube I am considering as t. And you will get a beta function. Try yourself. If not understood, I will explain it tomorrow also. I will explain it tomorrow. If you can't do these questions, I will explain it. Otherwise, let me do this question. Beta function question, no? It is 3x square dt. How the limits will be changed? Can you tell me? So 0 to 1 limits will not be changed accordingly. This will be like this only. X to the power 5. X to the power 5 is what? 3 by 2. So 1 by 3. T to the power 5 by 3. So 1 minus t. Okay. 10. 3x square. 3 by x square. It is. So it is what? dt by 3. X square is what? 2 by 3 only. So 0 to 1. T I am getting 1 by 3, 1 by 3, 1 minus t, 10. Okay, m minus 1. So here beta function it is. Beta function limits are satisfying. 2 minus 1, 1 minus t. Then it is here 2 minus 1 done. It is here again at 11 minus 1. So it is a beta function of 2 comma 11. It is what? Gamma of 2, gamma of 11 by gamma of how much? 13. Simplifying this like this, how much you will get? 2 factorial, 2 gamma of 2 is what? 1 into 1 factorial, which is 1 only. This is what? 11 gamma. So here it is 13 into 12 into, 12 into, how much I should write? 12. So gamma 11, 12 into 11 into 11. 11 is cancelled. 1 by 1, 12 into 12 into 11. So this is what? 120, 131, 132, I guess, right? This is the answer. You will get the answer like this, 132. Are you getting my point? How to get the answer? Next. Any doubt, please raise your hand.
So how are you recognizing whether the function is a beta function or a gamma
By
function?
practicing, you will get to know. See, beta function and gamma function, you always have to think once if the limits are from 0 to 1 or if the limits are from 0 to infinity. Always try to think beta and gamma function. And beta and gamma function are not the easy topic, believe me. It is considered to be the toughest topic in definite integration. In JEE syllabus, what I am teaching, actually in JEE syllabus, they won't be asking you this much. Okay? Don't worry. If this much of question, if you are practicing, that's more than sufficient. That will be okay. You will get the idea if you is required to put. Just practice this question. Whatever you have to put. So 3 root x s t. Substitute. You will get gamma function definition. You will get the function definition of gamma function. So these are the homework questions. 4 or 5 questions I am giving here. Easily you can do. Now what? This is also important relation. You should remember in your notebook, in your Chaitanya synopsis also it is given, mentioned, but not given as gamma or any function. You should remember this one. It is nothing but p minus a to the power m plus n minus 1 beta n, that is beta n is what? Beta mn is what? Whenever this type of question comes, you will be using this formula. For the proof, very simple proof, x minus a, b minus x. What we have? We know that we have to prove this one. The beta of m comma n is what? So the power is m minus 1, n minus 1. But here see, it is beta n and b minus a is multiplied. So basically we have to consider such substitution so that b minus a should be denominator here. B minus a should be denominator here, if you see. So I am considering the substitution like this. It should be x minus a, it was x only. So I am considering it is what t minus a by b minus a. Why? Because b minus a should be in denominator. If b minus a in denominator, it will come here only. तभी तो multiply or cross multiply. Then only it will be cross multiplied. So I am substituting like this. These are the way of substitution. But you will get idea. Dx is what? dt by b minus a. How the limits will be changed? X is 0. T is what? A only. X is 1. T is what? P only. The limits are changed accordingly. Therefore, beta of m comma n is equal to a to b. X is what? T minus a by b minus a to the power m minus 1. 1 minus x. 1 minus t minus a by b minus a n minus 1. This is what we are writing. Dx is what? Just let me write here nicely. dt by b minus a. All right. So doing this much, what we are getting, let me simplify it, a to b. T minus a to the power m minus 1 is what? B minus a. A will be cancelled. In b minus t you are getting c here. And in numerator it is what? B minus a to the power m minus n plus n minus 1 plus 1 into dt. If you just observe it, p m comma n, it is what? B minus a. This is a constant for this integration because there is no t involved. One t is cancelled to m plus n minus t. It is a to b, t minus a, m minus 1, p minus t, n minus 1 dt. So hence t and x and all these are the names of the variables. So we can write therefore, hence proved. A to b beta, x minus a, m minus 1, b minus x, n minus 1 dx is equal to p minus a to the power m plus n minus 1 gamma n pi gamma m plus n. I hope it is clear to you. This is the proof. Check it out. Yeah, raising your hand, someone. Yes, Mr. Dashyap, please tell me.
No, small doubt as to I understood all as to how you have solved from the start to end, but then how did you know that you would have to consider that x equals t minus a by b minus a? I mean,
these are the standard question first of all. But see, what I have said, there is some trick. These are standard manipulation for standard question. But again, there is some trick. What is the trick? See, if you observe it here, this is what we have to prove. B minus a should be here now. So we have started with beta n comma n. Beta n comma n is this one only. So this beta, ये क्या होगा? Beta n comma n is this one. So with this beta, we should be multiplying by b minus a to the power m plus n minus 1. So b minus a is originally the denominator of this part. But since this b minus a to the power this is constant for this integration, this can be cross multiplied. So we have to think that this should be in the denominator. So I am writing, and again the limit should be changed. And again it is what? X to the power m minus 1, it is x minus a. Here is x to the power m minus 1. So here I am writing x is equal to t minus a. Because t minus a to the power m minus 1 same limit and b minus a to the power m minus 1. So that I will get the idea.
So not getting it. I'm not able to understand. Could you please repeat again?
See, how to get the idea, what I am saying, what you have to prove. अपने को क्या दिया रहेगा? What we have to prove that idea is actually given the question itself. Here we have the beta function, this one. This is beta.
Yes, sir.
In the question it is x minus a. So writing x as t minus a. But in denominator it should be something so that it will be multiplied, it will be cross multiplied and you will get the result.
Yes.
So I am thinking that it should be in denominator. B minus a should be in denominator because if it is in denominator it can be multiplied and cross multiplied and you will get this result. So originally you will be thinking like that. That b minus a to the power something should be in denominator. So I am writing replacing x by t minus a by b minus a. Because t minus a to the power m minus 1 is this one only. Again after t will be replaced by x in the last step.
Yes.
So x minus a to the power m minus 1, this will be like this. And b minus a to the power m minus 1 and here, from here also you will get, and after simplification you may get this idea, you may get this result. So we are starting with the idea and we are starting with the idea and that idea is generated from by observing the question itself only.
Yes.
Got it?
Yes.
Got it? Yeah. Okay.
Please zoom out, sir. You have to write it. Thank you, sir. So for any such standard question, is that the only thing I can do?
Sorry?
For any such standard, I mean, for any such question, is that what I can do? Like
Yeah.
looking at the answer and then.
Yeah.
Okay. Thank you.
And see, obviously you have to remember the manipulations. In definite notation, in indefinite notation, the manipulations are very much difficult to remember, believe me. So you should write a note and you should practice it several times. Whenever you are revising, you should be remembering, you should be memorizing the manipulation. What type of question, what should be manipulation will be applied. These are the important things. Okay, otherwise chapter is not a big issue. But what type of manipulation is required? What type of substitution is required for which type of question? That all these things you have to remember. So this chapter is completely based on your memory also. Are you getting my point? There is very not so much concept is involved, but you have to, your memory should be strong. You should remember all the small manipulations to get perfect into this chapter. That's all. Next, last question I am writing. Last question of this beta gamma part. Beta gamma application, last question I am writing. Okay, beta? Prove that x to the power n e to the power minus k square x square. In all engineering, whatever we are proving in engineering, higher engineering mathematics, this will be proving, this will be treating as a formula. And very different tough question will be treating this as a formula. Several formulas are there, beta and gamma differential. Around 20 to 30 formulas are there. More than that maybe. So we have to remember all these formulas, and very difficult type of question will be treating this as a formulas. Are you getting my point? N is obviously greater than -1. Because whatever you are putting inside the gamma, it should be positive only. So n is greater than -1. This is the proof. This is one formula actually, but we are treating it as a question only. No need to remember. Obviously, you can't remember all these things. Again, you have to apply the gamma function. So whatever there is, e to the power x hota tha, e to the power -6 is there. So whatever there here it is, you will get the idea from this only. You have to convert into a form of gamma function. So e to the power -x hota hai wahan pe. So k square x square equal to t you will be writing. That is the hint. That's all. From here you will start doing and you will get the idea. What are the substitution? If x is 0, t is also 0. If x is infinity, t t is also infinity. That's all. There is no change in the substitution part. Dx is what? Dt by k square into 2x. X is what? T by k. This we are getting, right? This limits and everything we have to substitute now. Well, now, what I am doing here, try to understand. इसमें transfer करना है gamma. Okay, fine. We have to prove this one only, na? Okay, not an issue. We will be proving this one. Okay, fine. So here it is, 0 to infinity. X is what, beta? X is nothing but, X is simply, x to the power n is there. Root t by k is x to the power n. E to the power minus t is there. Dx is what? Dt by twice k root of t. Now the variable is changed to t. Limit is not being changed. For this integration, the k is constant. K to the power n, and here it is 1. T root t, t to the power n by 2 minus half. E to the power minus t dt. Okay. This 1 by k to the power n plus 1, and 2 is also there. 2 n plus 1 I am taking constant. I am taking outside from the integration. T to the power e to the power minus t is there. T to the power n plus 2. Na? So t to the power n plus 1 by 2, n by 2 plus 1 by 2, minus 1 we can write like this. Yes, correct. So it is nothing but 1 by 2 k to the power n plus 1, and it is, see, if you observe, it is nothing but gamma n plus 1 by 2 it is. And hence it is proved. You can check it out. N plus 1 by 2, 2 to the power k plus n plus 2 to the power 2 into k to the power n plus 1. Understood? So this is all about gamma, and this is all about what we have done today. It's all about gamma and beta function. This is what we have done today. It is sufficient. It is sufficient, believe me. Okay. Do the question. If you are getting some questions from any different book or whatever, you can do some practice, some questions. And let's see what type of questions they give in the examination. From that you will get the idea. Okay then. Let's move to the, you people are having some doubts in our advanced paper. Let's start with that, and this part is finished.